Hello, my name is Alex, and today we're going to talk about Stingle Photos application, and the talk is called Building Completely Secure and Private Google Photos from Scratch. So I want this talk to be a little bit more interactive, so whenever you have a question, just don't hesitate to ask in the meantime. So let me ask you one question. Have you ever used Google Photos or Apple iCloud or Amazon Photos? Please raise your hand. Okay. While using it, did you realize you are uploading your private and personal and sensitive photos to the cloud? And did you ever wondered what kind of security does it provide? Does it do they see it? What can happen to your information after you uploaded it? So you probably used it because you don't want to lose your photos and videos, and you don't have so much space on your device, and you want probably to upload them to the cloud and free it up from your device. But in fact, what happens when you upload all of your content to this one of these major providers, so they upload it in plain, so they don't have any kind of end-to-end encryption, and you just give them this information, and they do with it whatever they want. For example, lately they started using AI and machine learning to analyze your photos. You probably noticed that, for example, they can determine who is in the photos, what are you doing, where are you, where these photos were taken, and they aggregate all this information and they use it at best for their business needs. So you may ask, what's the deal here? What's the problem? So the problem is you don't know what for example, they cooperate with government agencies. They cooperate with other countries, like governments, police departments, etc. If they have, for example, a court order, they have to give up this information. So you may ask, for example, I'm not doing anything illegal, so what's the point here? So the point here is that in the future, you don't know what kind of governments will change, what kind of management of these companies will do in the future, and you really all this information can one day be used against you. For example, what if you become a famous person and your old photos or videos are used against you? Or for example, how you would feel, how many times we heard major and big companies, big services being compromised all the time, and they leak all their information. So how would you feel if, for example, all your photos and videos one day will be posted online? So I don't think that will be a very pleasant experience. So meet Stingle Photos. It's a zero-knowledge photo and video encryption and backup sync application. So it aims to provide maximum security and privacy and keep you as anonymous as possible without giving up the convenience of your everyday use of such application. So what happened a few years ago when I realized all this, that all these companies like Google, Facebook, Amazon, Apple, they collect so much information about you. After realizing the dangers of it, I started shifting myself from famous mainstream services. So I'm several years already I'm using Proton Mail as my daily mail. I use DuckDuckGo as my search engine, Turtle instead of Google Keep for notes, and so it's Signal for daily messaging. So, but the problem is I couldn't find any secure, end-to-end encrypted alternative for Google Photos. And I'm honestly have nearly 6 terabytes of photos. I keep all photos of my life, my whole library is really, really huge. So there was none on the market that like convenient application that could like replace Google Photos, or if you're an iPhone user, the Apple iCloud in your case. So I decided to build an application and named it Stingle Photos. Like he was asking like what Stingle means. Stingle is just a name. It doesn't mean anything, really. So. So how we achieve that? How we can be sure that we done how it's secure? Like how it can what we done for it to be secure? So first of all, it's a zero knowledge encryption. What does it mean? It means that like we don't see your information. You have the keys for encryption. You like manage your keys. We don't have it. We just keep the encrypted blobs in the cloud. And that's no good like for someone to see anything. Second is a solid cryptographic design. So we use like best practices in cryptography, and especially we're using Libsodium, which is a well-tested, well-vetted crypto library that includes like all the best algorithms there, nothing legacy, nothing old. So the application aims to keep you as anonymous as possible. We don't want to know about you anything. We just like need bare minimum just for it to function. So you just need an email and password for registration. That's all. We keep no logs at all, no IP logs, no usage logs, no analytics, nothing. App uses no third-party libraries, so we can be sure that we're not dependent on someone else's security vulnerabilities, watering hole attacks, this kind of stuff, and of course, app runs no ads, of course. And the fourth principle is being as open and transparent as possible. So I believe that great security application doesn't need to rely on obscurity. So it's not like, no, this is our proprietary design, we don't tell it about it to anybody. So no, we are as open as possible. We have like the security white paper which explains in great detail in every step what application does. And we believe that being an open design is having a good design is what we need. So, what an application can do? So it can securely store photos and videos on your device. You can take photos and videos with the built-in camera module, which are automatically encrypted. Backup your whole media library. Sync your photos and videos across all of your devices, and share your content with friends, family, colleagues, wherever you want. So basically, essentially it's the same functionality as the aforementioned applications like Google Photos, etc. But all with security and privacy in mind from the beginning. So. Let's get a little bit more technical. I want to really explain how the application works, so you can better understand why it's secure, be more confident using it, and we're going to talk about how the sign up and login works, what is the structure of encrypted files, how file encryption and decryption works, and the performance of the application. Also, so we're going to dive a little bit get a little bit more technical, so please raise your hand if anybody is familiar with basic principles of cryptography. You understand a little bit? Okay, so you got a little bit already from the quantum computing talk already, but let's get a little bit more intro into all of this. So there are really three main types of crypto, right? So there is symmetric encryption, asymmetric encryption, and hashing. So there are some examples of algorithms for each of these. So let's just explain a little bit more. So symmetric encryption, the idea is pretty straightforward. You have one key, you encrypt data with this key, and you decrypt to get back your data. You run the decryption algorithm using the same key. This is a symmetric encryption. Is that clear? Are you with me? Okay, so the next one is asymmetric encryption. Again, it's pretty simple idea. So it has pretty complex math behind it, as you saw earlier, but we're not going to dive into it. So, but the idea is pretty simple. So you have two keys. We just name them public and private key, and the idea is you encrypt with one key, and you can decrypt only with the other one. Really doesn't matter which one is which. We just name one of them private, one of them public. So there is just no way to decrypt information with the same key that you encrypted. You need the other one, and there is no way to get one key knowing the other one. So this is a basic principle. So third thing is hashing. It's not really encryption. So what hashing does, you have like, you give it some data to the hashing algorithm, in this case, for example, SAJ256. You give it some data with arbitrary lengths, and it returns you the fixed length result. For example, the data can be 1 character, can be 1 terabyte of data. It will always return the fixed length result. And having the same data and same algorithm, you always get the same result. But knowing the result, there is no way to get back to know what the original data was. So, hope this is clear, pretty straightforward. Okay, so let me introduce to Argon2 key derivation algorithm. So what is key derivation algorithm? If you think about it, if you want to encrypt some data with using a password, you really don't want to use a password directly. Why? Because first of all, passwords can be pretty weak and not very complex. And second, most of the encryption algorithms, they want fixed length key. And so for that, you need to derive some kind of a key from a password, which we'll use for the encryption. So the Argon2, and the other problem is, for example, when you encrypted something with a password, if you think about it, if someone wants to break it, they need to brute force, try all possible combinations of the passwords, or try different passwords to guess your key and decrypt your data and hack it. So our main goal here is to slow down hackers and brute forces as much as possible. So what we can do, for example, we can hash not once, but many times. So take hash, take the result, hash again, take the result, hash again, do it 10,000 times. So it means for one try, attacker will need to do this 10,000 computation and then try it once. But if you think about it, again, there is, thanks to the cryptocurrency boom and crypto mining, we have specialized hardware which does just hashing. And they can do, for example, tens of millions, trillions guesses per second, computations per second. And having all this hardware, it makes really easy for the attackers who decided not to mine, but to crack passwords, for example, or hashes. So what we need to do here, so the Argon2 finally came back. So the Argon2 does what? It does both computationally and memory hard work. So what does it mean? For each try, for each derivation, it needs to do a lot of computation work, which requires a lot of memory. And ASICs don't have a lot of memory. And for each one of these computations, you need certain amount of memory, and this just obliterates all GPU, ASIC, and FPGA acceleration. And it means you need to use your plain old CPUs, which are pretty slow, which makes it really infeasible to even try brute force attacks. So, and the best part of the Argon2 algorithm is it's configurable. So you can give it parameters and say, for example, I want this much work, this much memory, this much work, this much memory, so you can play it and use it differently in different situations. So there's three main difficulties of Argon 2. So interactive will take 0.1 seconds on 2.8 GHz i7 CPU, and it requires 64 megabytes of RAM. Moderate is 0.7 seconds and 256 megabytes of RAM. And sensitive really takes a long time, it's 3.5 seconds and 1 gig of RAM. So just made a calculation to brute force 6-character password that contains lowercase, uppercase, and a digit, no special characters here. And for each guess, if it is taking half a second, you will need 1,000 years. So just think about it, and when choosing your password, like try to choose at least 6-character or 8-character password, which contains like also special characters. You will be like totally okay. So what kind of algorithms we used in Stingle Photos? As we already told, like symmetric algorithm is XChaCha20 with poly 1305 authentication. You don't really need to like dig in what it is. It's just a very strong and secure symmetric encryption algorithm. For asymmetric, we use elliptic curve crypto with 25519 curve, which is developed by world famous cryptographer Dan Bernstein. And for hashing, you guessed it, it's Argon 2. Okay, so let's get back to our application finally. So when you first open it, you probably want to register and create an account. So what the application does when you fill up your email and password, it generates your key pair, your public and private keys, which really your private key is your main secret here. So it derives key from your password, as we already discussed with Argon 2. It encrypts your private key with key derived from your password. Then it derives token from your password registered with the server. And if user chose to, it backs up your private key, which is re-encrypted with Argon 2 moderate difficulty, and sends it to the cloud. So if you think about it, if you lose your private key, then it's gone. Like all of your data is gone. It's impossible to recover. If you chose not to back it up, then you have the responsibility for backing up yourself and keeping it like safe somewhere where you don't lose it. But if not, so app can take care of it. And if given that you chose pretty like strong password, you don't have to worry about backing up your private key there, because it's like encrypted, like hashed with moderate difficulty, and it's really like impossible to brute force it. So to log in, the flow is pretty similar. It authenticates with the server with a token derived from the password. It downloads your backed up keys, or asks for a key if it doesn't have the backup. Derives key for decrypting your private key, re-encrypts it with interactive difficulty. So on locally we store private key encrypted with interactive difficulty, so you will have it will be very fast to unlock the application and use it every day. But for backing up or sending it somewhere, we use like more strong difficulty. So let's talk about encrypted file format. So each file, each photo or video you take, it encrypts, and the encrypted file has like some kind of a structure. Some kind of format. So it really like consists of the encrypted header and encrypted data. And header is encrypted with your public key, and there is stored your symmetric key for decrypting data symmetrically, and some kind of other metadata like file type, file name. If it's a video, then video duration. Really, this is a really simplified version. So in fact, it looks like this, but we're not going to dive into it. If you want to like dive more deeply, you can read the security white paper. So to encrypt a file, we have a file, we want to encrypt it. We just gather all the metadata, like its size, its type, its video duration, I don't know, all this kind of stuff. Then we generate 256 random master key. We construct the header, encrypt the header with the public key, and write the encrypted header, and using Blake 2B algorithm, I'm not going to dive into it right now. We just derive separate key for each encryption block. So we encrypt the data of the file in blocks. I will explain now why. And we derive separate key for each block and do our encryption with aforementioned ArmSec2019 Poly 1305 algorithm. So you will ask, like, why it's so difficult? Why it's so complex? Why it need to be like this? Just take the password and encrypt the whole file with that password. Isn't it? We will be good. So why we did this? All of this stuff. So because first of all, we need to be able to take photos without unlocking the app and giving it a password, right? So we want to take your phone, take a photo without entering a password. And it encrypts the file using your public key, and to view content, you will need to provide password to unlock your private key. So remember, so one key encrypts, the other one decrypts. So that's why you can take photos or import them without knowing anything, without providing anything to the application, and your public key is open all the time, available on the device. Second, as you noticed, all metadata, like file size, its type, everything is considered secret too. So even, for example, from the encrypted files, we can't tell which kind of file it is. Like, is it a photo or video? What size did it have? Like at the beginning, all of this complements the idea, like that we're trying for it to be as anonymous as possible. So, and why we just did like encryption in blocks? Because, for example, we want to able to seek video. For example, jump to the end of the video right away without needing to decrypt the whole file. That's why we need to be able to decrypt each block independently. So, all of this, like a little bit of overview of the technical part. So, what about performance? So, I personally believe that if the application is not convenient to use, is not like it can't replace Google Photos, for example, in your daily life, then doesn't matter how secure it is, right? Because if nobody using it, it doesn't matter how secure it is. So the main focus was like usability, like to be like this ordinary, your usual experience of your ordinary gallery app. So the security and encryption doesn't come into your way. Why ArmSec20? Because it's much faster than AES, like industry standard, like famous AES, and AES really faster on desktop CPUs, where it has like CPU specific instructions for AES, but that's not the case on mobile devices, and AES really struggles on mobile devices. That's why ArmSec20 is much better choice here. And there is one more thing, to speed up gallery, like when you scroll through your gallery, if you think about it, it will be really like burdensome to decrypt large files to show you thumbnails. So on every file creation, app generates thumbnails and encrypts them, of course, in the same way. So, of course, thumbnails are secrets too. So, app also can do backup and sync. So it automatically backs up your encrypted files to the cloud and syncs them across your devices. So there is no need to be nervous about that, because I can really confidently put all my encrypted files for public download and be sure that nobody can get anything from that. I'll tell you more. My initial idea when making the whole design and the crypto design of the application, main goal was to build such an infrastructure, such an application, that, for example, in an unlikely case that, for example, hackers get in They steal all source codes, steal all databases, steal all files, steal all user data. They should not get anything from that. So there should be no real like incentive for doing that, because server doesn't know anything about you. It just stores the encrypted blobs, which you can't decrypt. You can't do anything about that. And so if something like that happens, they should not get, like, they will not get anything useful after that. Actually, server knows about you, cloud infrastructure. So it's pretty like, here's the complete list of things that we can see about your account. So your email, your sign up date, how much storage are you using, what's your current plan, number of uploaded files, size of encrypted files, number of devices that are currently logged in with your account, and have you confirmed your email address or not. That's it. Like, nothing else. So this is just bare minimum that allows the application to work. Okay, so it's good to talk about that it's very secure and very good, but let's talk about when it fails to protect you. So first of all, it fails when your device is rooted and you have root level malware. Root level malware can interfere with other applications' memory, and while unlocked, it can steal the private key from the memory. So on the normal phone, that's not possible. One application cannot access memory from the other one. Or it just can trivially plant a keylogger and just grab your password when you're typing it. So just be aware, use like authentic phones, don't root them, don't install some shady applications. It will fail if your password is A or password. Or for example, if you just said someone your password, or I don't know, gave it, someone guessed it. So pretty self-explanatory. So how much does it cost? It's free. You get 1 GB of free cloud storage with every account, and you pay only for more cloud storage. As I told earlier, there are no ads, no analytics, like nothing at all. And application is in beta right now. So if you're interested, you can join the beta test, and all beta testers will get 10 GB of free storage for the lifetime of their account. And also join the official Telegram channel where all the discussion goes. So thank you very much. That's the application. Do you have any questions?
Does it work on all platforms like Windows, Mac OS, Linux, and so on?
No, it's an Android app, yeah, but the desktop version will come, and yeah, by the way, we are planning to release desktop version to make it completely open source, which is basically the same code, just with the different UI, to make it like, to complement the idea to be as transparent as possible, so you can like see the code, analyze it, and be sure that it does what it promises.
And about charging, is it the same price for user and for companies, and for private sector?
So just it's right now it is, but for corporate use, we're planning to do some bundle packages in the future. So it's just finishing the development of first version. As I told, it's in beta still, so a lot of more features will come in the future. But of course, all of them are around security in mind first. So that's the main goal and the main purpose of this application.
First, thank you for your speech. I wanted to know, does your product has a public API? I mean, can I use your product as a resource for my application? Something like Amazon's S3. Thank you.
We don't have public API right now. I'm not sure why you will need that. So it has the API server, of course, to upload and to sync to.
For other applications.
Can you describe the use case, for example, for what you will need that?
For example, I have a product. I have users that they wanna store their images, but I don't have a resource for their images, and I want to use your application. Have you heard about Amazon S3?
Yes, of course.
Yeah.
It uses S3 underneath, for storing your encrypted files.
Okay.
Yeah, so this is a nice idea. So I'll take that into consideration. So, for example, you have the application which wants to save images or some kind of files in a secure way.
Yeah,
Only your
exactly.
But only your service can access them. So your service will have keys for that, right? And yeah, okay, yeah, that's a pretty nice idea. Yeah, we'll take that into consideration. Thank you.
So if I got it right, I don't know if you know about Bitwarden, I'm sure you do, the open source password manager. You're following the business plan or the model it has. And I just wanted to know how open source your application gets. I mean, can I self-host my own server to back up my photos to my local server and not to a generalized global server?
It's not open source right now, so the Android application I think will not be. Some parts of it will be open source, and also, as I told, the desktop version, like for Windows, Mac, and Linux, it will be fully open source. As for deploying your own server, we don't have such thing in plans right now. But I think it will make more sense for enterprises to have their own server to use as a storage. But really, the thing is, the beauty of this scheme is that really doesn't matter where you store them. As I told you, you can even store them publicly on the internet for everyone to download. So your encrypted files are so secure, and they're not brute forceable. If you were following my talk, so the files are encrypted with random 256-bit key, and that key is encrypted with your public key, and your password encrypts the private key. So it means that your password doesn't contribute to the encryption of the actual files. So files are not brute forceable because they're encrypted with fully random 256-bit key, and if you do the math to brute force 256-bit key, more atoms than in a universe. So it's impossible task. That's why it really doesn't matter where you store your encrypted files. But for example, for corporate, key backups, one can probably think about deploying their own server.
What will happen if I forget my password? Is there any way to recover it?
Yeah, so it's in the works right now. It's not right now in the application, so it will be ready in 1 or 2 weeks. So of course there is no way to recover it. Otherwise it will be pointless. We can't change your password. We can't remind your password. We can't send you a link to reset your password as all of the other services, because we don't have your key to re-encrypt your key. That's why we can't change your password. But what we're planning to do, what's in the works, you can have you ever used cryptocurrency wallets when it gives you a seed phrase? So some words you have to remember which can construct your key. So we are doing the similar thing. So after registering, you will be given opportunity to back up your key. And there will be some just English words in certain sequence, and you just write them down or write them in Bitwarden, for example, or some secure place. And if someday you forget your password, you can get your private key back using that phrase. Okay, any other questions?
Oh, one more, please. Thank you very much for presentation. Just not a question, but I wonder whether you keep all the data in one big space or you distribute it in different parts in case maybe of someday a possible hacking. All is leaked, all partially will be leaked.
Right now we're using Wasabi hot cloud storage. It gives us, it has great redundancy itself. It's like a big cloud storage company. But we're planning to, it gives us opportunity to keep the prices for more storage really low, so really affordable. So if you saw that on the screenshot, it's nearly like, it's for 1 terabyte, it's just, oh, I think it's something wrong here on the screenshot. So it's just, yeah, it's just $12 a month for 1 terabyte, and terabyte is really big. But in the future, when we get some more traction and some users will come, we'll probably do some more redundancy to use like 2 cloud storages different if something happens to one of them.
Thank you.
Okay.
Any more questions? No? Okay, thank you.
Okay, thank you very much.